what are both integers n which satisfy n squared plus n to the power of 4 is equal to 2 to the power of 2 plus 2 to the power of 4? Well, just by inspection, if you look at the numbers, n squared, n 4, and then on the other side you have 2 squared plus 2 to the power of 4, obviously n is equal to 2. But then they're saying both, so there's got to be another one. So you say, okay, well, what could it be? Well, since these powers are even, if you put in a negative 2, that would also result in that, because it would be negative 2 squared plus negative 2 to the power of 4, and that would, when you square it, it becomes positive, so it would be the same as 2 squared plus 2 to the power of 4. So the two values of n that they're asking for are 2 and negative 2. If x plus y is 2001, 1 over x plus 1 over y is 2001, what is the value of xy? X plus y is 2001, and then they give me that 1 over x plus 1 over y is also 2001. Okay, well, let's add this fraction, get a common denominator, top and bottom. That would be x plus y over xy is 2001. Well, x plus y is 2001, so that 2001, I guess I'd just put in there, and then that pretty much means that xy is equal to 1. And I think that's all they were asking. What are three unequal positive rational numbers ABC for which a plus b plus c is equal to 1 over a plus b plus c? Well, they're positive, so all of them are greater than 0. And they're rational, so they're not necessarily integers. Okay, well, let's take that equation and work with it and see what we can do. So a plus b plus c is equal to 1 over a plus b plus c. Cross multiply, and we get a plus b plus c all squared. And then take the square root of both sides, and a plus b plus c would therefore be 1. Right, because it can't equal negative 1 because all of these guys are greater than 0. So there's no way that three positive numbers would add up to negative 1. So the negative 1 option is not valid. Okay, well, it looks to me like since a plus b plus c is equal to 1, that is an infinite number of possibilities. The only thing is that they're unequal. So, like, for example, they couldn't be 1/3, 1/3, 1/3. That's sort of the obvious one, right? That a equals 1/3, b equals 1/3, and c equals 1/3. Well, that's wrong because they're unequal. So that's not valid. So you just have to come up with three probably fractions that add up to 1. And let's see here. So for example, if a is equal to half, and b was equal to 1/3, and c was equal to 1 over 6, right? Yeah, that would work, because 1/2 plus 1/3 plus 1 over 6 is equal to 1, because this would be, let's say, common denominator. It would be 3 plus 2 plus 1 over 6, and that is indeed 1. Yeah, so there's infinite answers. They just want you to find what are three unequal positive. Just one possible solution, and this is one possible solution. And I'm just trying to think, how would they grade this? Because there's so many infinite. I guess as long as the three numbers you chose add up to 1 and they're unequal, then that would be correct, I guess. The All-Stars are one of 16 teams that play in the Community Softball League. What is the total number of games played in the league if each of the 16 teams plays exactly 3 games with every other team in the league? So we have 16 teams and they play 3 games, so 48. But that doesn't really take into account that they're playing every other team. So we got to think about this here. So we've got 16 teams, right? And from each of those teams, from those 16 teams, you have to choose 2 for a match. And that's 16 times 15 over 2, so that's 120. So that's how many pairs you have. Yeah, so for example, Team A is paired with Team B. That's a pair. And then that happens 3 times. Each pair would play 3 times. So then you take that 120 and then multiply by 3. So that is the right approach, I believe. 360 would be the answer to this question. What is the sum of the digits in the number equal to the product? All right, so this is a huge number here. And so let's analyze this. We got an 11, and that 11, okay, and then we have 101. Then we have 10001. Then we have 100000001, and then finally we have this. Oh boy, how many? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'll just put in that. So 15 zeros. Okay. So we got 15 zeros. This was how many? 1, 2, 3, 4, 5, 6, 7 zeros. This is 3 zeros, and this is of course just 1 0. 1, 3, 7, 15. So we're not, what is the pattern? Are we doubling this every time? Doubling and then adding 1, right? This would be 2 plus 1 is 3. 3 times 2 is 6. 6 plus 1 is 7. 7 times 2. Okay, so whatever that means. I don't know if that helps in any way. Well, let's see what happens. Let's take this one step at a time. Let's see if there's some kind of a pattern. Okay, so the first thing I'll do is just these two guys. 11 times 101, right? Eleven times 101 is 1111. 11 times 101 is what I should be saying. And the number of ones I will write over here. So this is obviously 4 ones. And this is what? Well, this is 10 to the power of 3 plus something. Well, in this case, it's 111, correct? Yeah, because 10 to the power of 3 is 1,000. Okay. Well, I don't know if that helps in any way, but let's just keep going here. So now let's look at the 3, this, and this, all multiplied together. And if you do that, you will get 1, 1, 1, 1, 1, 1, 1, 1. Correct? So what does that tell us? Well, let's first count the number of ones. That's 8. And this is 10 to the power of 1, 2, 3, 4, 5, 6, 7. 7. 10 to the power of 7 plus a bunch of stuff, plus a bunch of ones, right? And then I'll just put that in brackets. I don't really care what that is. I'm just trying to get an idea of what this could possibly, because they want you to eventually figure out the sum of the digits. Well, the sum of the digits looks like a whole bunch of ones. I just have to know how many ones there are. Because the sum of the digits here, let's say sum of digits for this guy is 4 times 1, which is 4. Sum of the digits for this guy would be 8 times 1, which is 8. You see what I'm saying? So if I get a pattern, I should be able to figure it out. Now let's do it for these 4. That would be 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, so how many ones is that? 16. And that is obviously 10 to the power of 15 plus a bunch of stuff. And the sum of the digits is 16 times 1. Oh, wait, hold on. No, yeah. No, how many? Wait, hold on. Yeah, I think that was right, actually. It would be. It's 16. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah, so 16 times 1. So the very last one, when I multiply all of them, my gut instinct is that it's going to be 32. So 32 of these ones, I don't, obviously you guys get the point. And the sum of the digits would therefore be 32 times 1. So a little bit of extrapolation is all that's required. And you are allowed to use calculators on this exam, so that would help also. A circle is inscribed in a Gothic arch. As shown, what is the area of the circle if the base of the Gothic arch is a line segment of length 24 and the other two sides are minor arcs of congruent circles centered at the ends of the base? So let's draw this and let's see what I can do here. And I've got to draw a circle. Okay, that's pretty decent. Not perfect, but it's okay. Okay, so now let's set this up here. So let's draw the center and let's draw a line like down to the bottom. So that's going to be a tangent. And this is also going to be a tangent, and so will that guy. The spot where the circle touches the arch, whatever. And then let's label the radius r of that circle. And let's then draw a line from here to here. And that I don't know yet. Now they're saying the line segment, the base is 24, so this is 24, and then from here to here, that would be just 12, right? Because it's half because of the symmetry of the diagram. Okay, now what else can I do here? Well, a circle is inscribed in a Gothic arch. What is the area of the circle if the base, the other two sides are minor arcs of a congruent circles? Okay, I think I understand. So this is the story here. This arc is part of a circle. They haven't drawn the full circle, but if you did, it would be like this. See what I'm saying? And this is the radius of that large circle. So this is obviously the center. So the radius of that large circle is 24. Okay, I got it. So that means if I drew a line from the center of that big circle all the way to there, that's also 24. And since from here to here is r, that means that this would be 24 minus r. Correct? So that means 24 minus r is this guy right there. Okay, so we got a Pythagorean relationship. We have 12 squared plus r squared is 24 minus r squared. Okay, so let's just expand that. So we have r squared plus 144. And that's going to be, let's see here, 24 squared minus 48r plus r squared. The r squareds cancel on both sides. So all you are left with is 48r is 24 squared is 576, I believe, minus 144. 576 minus 144 is 432. And then therefore r would be equal to 432 divided by 48. And that is equal to 9. Now, be careful. That's not the answer that they're looking for. They're looking for is the area of the circle. So the area of that circle obviously is pi r squared. And since r is 9, it would be 9 squared. And therefore it would be 81 pi.